class, so welcome to week 5 of our building technology 3. So today we're going to discuss about some architectural finishing systems. Okay, so we're going to have a short discussion on this. Okay, so this is an example of a suspended light gauge ceiling system, where in here you can see this is the hanger, this is the cross T, this is acoustical lay-in panel, this is the main runner, and this is the wall angle. Okay, so the distance between the bottom of your slab up to this ceiling here, it's what you call the plenum. Okay, so it's important to know that because I think it would come up in your board exam. It's also important in your future practice. Okay, so usually this light gauge ceiling system is made up of aluminum. So this one. Okay. So this is what you see commonly in office buildings, in some malls, etc. Okay. So here, you can see in the lightweight system, seating system, you can see that there's an access angle. Okay. So it's important, class, that when you design your ceilings, there should be a manhole for access in case that you need to maintain something within the plenum. Okay. There's the firing system. So this is another example. As you can see in the drawings, you can always see that there's a hanger wire. Okay. So basically, the details of these aluminum frames, it would differ from supplier to supplier, but this is the general shape of it. Okay, so the next is your uh, raised floor system. So this system is used in general construction or small computer rooms. It provides maximum accessibility, optimum underfloor space, and electrical continuity. Note that it is dependent on panels being restrained by perimeter walls. Maximum load is 150 pounds per square inch, and the concentrated is 400 pounds. Okay, so this is example. So this is the floor panel. This is the vinyl edge trim. It's a steel lug, a steel pedestal head, the steel tube, the locking nut, then the solid steel stud, and then the steel base plate. So it's a minimum of 4 inches to a maximum of 12 inches. So basically, the purpose of your raised ceiling class is to let the wires uh, from for the computers or for the electrical systems go under your floors. Okay. Just remember, class, that when you want to use the raised floor systems, I think it will be much better if you already considered it already in the design in the beginning. Okay, so you won't have a hard time when you construct your building or structure. Okay, so this is the panel lock. So this system is used in general construction and is designed without a stringer connection at the edge. Bolted at the corner, it provides added rigidity over stringerless systems and maximum access and flexibility. So this is the access floor panel, the fastening screws, the steel pedestal, steel tube, locking nut, steel solid steel stud, and a steel base plate. So this is the general detail for it, but like what I've said earlier, it would really depend from supplier to supplier. So I encourage you guys to visit construction exhibits and then talk to the suppliers there on the various uh, services that they offer so that you have advanced knowledge already, because these are important systems, not like what I've said earlier, not only in your for your board exam, but also for your future careers as architects. Okay, so this is an example of snap-on grid. The system is used in computer rooms. In computer rooms and in general construction where frequent access is required, it provides improved lateral stability when compared to stringerless systems, electrical continuity, and plenum seal. Okay, so snap-on grid. So this is the access floor panel, the vinyl edge trim, snap-on stringer, steel pedestal head, the steel tube, the locking nut, then the solid steel stud, and the steel base plate. This is the rigid grid. So this system is used in computer rooms and areas of heavy loading. It provides maximum rigidity for seismic or dynamic loading, electrical continuity for grounding or static control, and plenum seal. That's a maximum load of 400 pounds per square inch and a concentrated load of 1,250 pounds. Okay. So why is it last that these raised floor systems they consider a lot of heavy loads? Because last your servers they are quite heavy. Some are large. So and then when you place equipment in the room, it would require something strong enough to carry the load. Okay, that's including the load of the people moving inside. Okay, so you can just imagine if this is weak, then you have a very heavy person passing by, then the entire floor would collapse. Okay, that's why what I've told you, um, when you design your buildings, consider this already. And then you want to have a raised flooring, consider it already in the early stages of the design so that you can talk with the suppliers first so that you can integrate it seamlessly in your building design. Okay, this is some of the details for it. Okay. You can take a screenshot of this class, pause the video and then take a screenshot. Okay, so these are sample of light gauge steel studs. Okay, so this is the diagonal strap bracing welded to studs and runners. Okay, this is a secure strap here. Connection to stud and runner with a steel gusset plate or weld. This is the angle clip welded to stud and bolted foundation. These are the light gauge stud assembly at corners. This is a horizontal channel bracing. Okay, the light gauge steel studs and continuous runner channel. It's a spliced runner sections to the stud section. Okay. So, class, usually you see these systems, the light gauge steel studs, you see this usually in office spaces, but you rarely see this in residential buildings because it would be quite expensive glass to fill in the gap here. Okay. So this is your steel studs, you're going to have to place your hard flex on both sides, but there's still going to be a gap. So in that gap, you'll have to spray some foam to, to make sure that there will be acoustic insulation from both sides. In residential areas, some a lot of contractors and even building owners find it more what you call this find it more convenient to use hollow blocks because hollow blocks it already has good thermal and acoustic properties. Okay. But the advantage of this one is that it is cheaper if you exclude the filling in between. Okay. That's why this is ideal for office spaces and for areas wherein you don't need much uh, acoustic consideration. So these are the details. So what you call a C stud. Okay, so you can see it is forms a letter C, and it's slightly bent here. So it's 1 1/4. There's 1 3/8, 1 1/2, 1 5/8, 2 1/2, 3 inches. Okay, so these are the different sizes. But it would also differ based on where you're going to get your supply for this. So what you call this channel studs. So it's the difference in C studs is that it's just straight here. There's no bent here like here. Like C. Okay. So it's just straight one without you can't see here that there's a bent portion. So light gauge steel studs are usually pre-punched to allow piping, wiring, and bracing to pass through. Okay. So consult manufacturer for specific sizes. So light gauge stud walls are frame, sheet, insulated, and finished as a wood light frame construction. So this is an example here. So this exterior wall sheeting and finish. The perimeter channel fastened to webs stiffeners and clip angles. It's a continuous runner channel, light gauge steel joist here. This is the web stiffener. This is the uh, clip anchor bolted to concrete and foundation wall. So this is really important because it would keep your studs from moving. The continuous runner, perimeter web stiffeners, light gauge steel studs, continuous runner channel. Okay, so this is how you do a detail class uh, for light steel studs or light gauge steel. Okay. You don't see this usually here in the Philippines, but when you go to other countries, these are the what they commonly practice there. So you can imagine that their construction is much more precise compared to us. But then again, our weather here is different than the climate, and we also have some problems when it comes to climate, the seasons, the typhoons. So you really have to consult with your have a meeting with the rest of your team before you decide to use this system here. Here in the Philippines, I'm a fan of concrete hollow blocks. But the problem with them is that when you construct them, you have to really supervise your people to make sure that it is plumb and straight. Okay, so here's examples for the connections for um, the exterior wall. So it's a light gauge steel stud. This is the continuous runner channel. It's the reinforced concrete on metal decking. So your metal deck class, you just use a sheet of metal. You know, fill it with concrete. Then use the suppliers or manufacturers specification on the distance between the rebars or other reinforcements. So this is an open web steel joist. This is a stud beam or light gauge steel stud bearing wall. This is an example for the interior wall. Okay. This is a double channel here. This is a continuous runner channel. This is a light gauge stud bearing wall. Okay. So this is another view for it for exterior. Then this is a stud assembly at partition intersection. Okay. So this is a steel gusset plate here. This is a truss header, double C joist. Truss bridging at corners next to openings. This is a double or nested stud. There's a structural steel channel here. Okay. These are the types of light gauge steel joist. So you have a nestable joist, the C joist, and the joist closure. So this is the detail if you do this in interior bearing. This is for exterior bearing. So this is the wood panel deck. This is the steel joist continuous or laps with adjoining joist over beam or wall support 3 inches 75 minimum bearing at interior support. This is the web stiffener, the double joist under partition loads. This is the metal stud wall. This is the continuous runner fastened deck to closure channel. This is the perimeter closure channel. This is the web stiffener. This is the 1.5 minimum bearing joist at ends. This is the steel joist and the metal stud bearing wall. Then let's go to metal cladding. So I think from this PowerPoint, they introduce this alpolic or interior alpolic. So features are its lightweight, its flatness, workability, impact resistance, sound transmission, corrosion resistance, and thermal insulation. But there's a lot of metal cladding available nowadays, class, when you check with your different manufacturers or suppliers. So for alpolic here, consider this the fluorocarbon paint finish. It's a 0.5 mm aluminum skin, polyethylene or non-combustible mineral filled core, 0.5 mm aluminum skin is the service coating. So these are features: flatness, rigidity, impact resistance, workability, and fire resistance. And some of the projects, I think, where it was implemented, you hear the PLDT building. So familiarize yourselves with different buildings last, because uh, more than often this could come out in your board exam. This is the Mansara Mosque in Kuala Lumpur, Malaysia. So it's really nice. This is the 400 George Street in Sydney, Australia. Okay, so it's a really metallic. Hewlett Packard Building, Los Angeles. Okay, so the processing method is the cutting. You're using square shear, panel saw, table saw, circle saw, knife cutter. Then you're going to bend it using a press brake, a roll bender. Then you're going to join using a rivet, bolt, adhesive, welding of polyethylene core. Okay, so these are some of the installation examples. So let's, okay, zoom this one. So this is the butt joint. Okay, okay. So you can see it's butt because it's side to side. This is the ceiling joint. So you're going to have a sealant here. This is the open joint. So there's an opening here. This is the joiner, aluminum or stainless steel here. Okay. Okay. Okay, so this is a rectangular pipe. This is a wallpaper paint finish. This is the edge bar aluminum. Okay, I can't seem to move this. Okay, let me move so that you can see it. Okay, so this is the internal angle. So this is the press brake or bending. It's only used for only alcoholic. This is the corner bar here. This is another example of a corner bar. So here it's more of a curve, and here a joiner. So you have an aluminum joiner, and here sample of a U-groove bending. Then here for the ceiling, here for the corner bar. Okay, so I hope you learned something from our short lecture class. So if you have any further questions or clarifications, don't hesitate to send a message on Facebook or send me an email. Okay, so I'll always reply class as long as I'm online. Then if I can see your message as well. Okay, so I hope you stay safe. Then try to look into different details class from different books, and try to read some brochures from suppliers as well. Okay, so please learn beyond our lesson, because it's really hard right now, especially here in the pandemic. So I hope that um, that you learn something. I really hope that. Okay, so see you next meeting class, and stay safe.